Yeah. Today's our topic is what? Buffer solutions. The topic name is what? Buffer solutions. Okay, buffer solutions can resist what? The change in pH value. If you add little quantity of acid or base, if you add a little quantity of acid or base to the buffer solution, there is no change in pH value. The pH value does not change. That is called buffer solution. Okay, ma. Suppose you take here several purposes. We need solutions which should have constant pH. There should be constant pH. Suppose blood is there in our body. The blood has a constant value of pH. Okay, there should not be any change in pH value of blood when we consume some acidic substances as food and some basic substances as food. Okay, many reactions, particularly the biochemical reactions. Biochemical reactions, nothing but digestion, the reactions involved in digestion, the reactions involved in photosynthesis, the reactions involved in respiration. These all things are called what now? These all chemical reactions are called biochemical reactions. Okay, particularly the biochemical reactions are to be carried out at a constant pH value. There should be a constant pH value for respiration process. There should be a constant pH value for digestion process and so on. But it is observed that solutions and even pure water with pH value 7 cannot retain the constant pH for long time. For long time, the constant pH cannot be retained by most of the liquids and solutions. If the solution comes in contact with air, if any solution comes in contact with air, it will absorb CO2. CO2 is acidic oxide or basic oxide? CO2 is acidic oxide. The non-metal oxides are what? Acidic oxides. So the solution will absorb CO2 and becomes more acidic. The solution becomes what? More acidic, because CO2 is acidic oxide. By absorbing acidic oxide, the solution becomes more acidic. The solution is becoming more acidic means pH value is decreasing. The solution is becoming more acidic, meaning what? The pH value of the solution will be decreasing. That is the meaning to be understood here. That means pH is changing here. There is no constant pH value. If the solution is stored in a glass bottle, if you store the solution, okay, alkaline impurities dissolve from glass. Alkaline means what? Basic. Alkaline meaning what? Basic. The basic impurities will be dissolved in the solution. If you store a solution in the glass bottle, what happens now? The alkaline impurities, the basic impurities, dissolve from the glass and the solution becomes alkaline. The solution becomes basic. Is the concept clear? A solution whose pH is not altered means not changed. A solution whose pH is not changed, not altered to any great extent, by the addition of small quantities of either an acid in the form of H plus ions or a base in the form of OH minus ions is called the buffer solution. So what we have to how to define the buffer solution? A solution whose, it is definition of what? Buffer. A solution whose pH is not altered, not changed to any great extent by the addition of what? A small quantities of either an acid or a base is called, that solution is called the buffer solution. The buffer solution. It can also be defined as a solution of reserve acidity or reserve alkalinity. A solution of reserve acidity or reserve alkalinity which can resist the change of pH. The change of pH upon the addition of small amount of acid or alkali. Acid or base. Alkali means base. The soluble base is called alkali. So by adding small quantities of alkalis or acids to the given solution, if there is no change in the pH of solution, that means if the solution resists what? The change in pH value, such a solution is called what? Buffer solution. Is the concept clear, ma? So by adding a small quantity of an acid or a base, if there is no change in pH value of the given solution, which is called buffer solution. Buffer solution. Is the concept clear? Okay. Next, general characteristics of a buffer solution. Okay, a buffer solution has which type of properties, which type of characteristic properties we have to understand. Okay, so it has a definite pH value. The buffer, it means what here? Buffer. It means what here? Buffer solution. So the buffer solution has what? A definite pH value. That is, it has reserve acidity or reserve alkalinity. Okay, reserve acidity means some buffers will have acidic nature. Some buffers will have acidic nature and pH value of some buffers will be less than 7. They are acidic buffers. And some other buffers have the pH value more than 7. More than 7 indicates what pH value? The buffer is basic buffer. Like the different types of buffers there that we are going to discuss. Okay, first you remember that the buffer solution has a definite pH value. That is, the buffer solution has reserve acidity or reserve alkalinity. Okay, and its pH does not change on standing for long time. It means what? The pH value of buffer solution. Its pH meaning what? The pH value of buffer solution does not change, does not alter. Alter means what? Change. Does not change on standing for long time. Suppose some buffer solution is there. The buffer solution is taken in one vessel, small vessel, and kept aside for long time. So on long time standing, okay, there is no change in pH value of the solution. Okay, if you keep a buffer solution aside, if you allow it to stand for a long time, there is no change in pH value of the buffer. That is another characteristic property. And the pH value of buffer, its pH does not change. Its pH does not change on dilution. Dilution means what now? On adding water. On adding water is called what? On dilution. Addition of water is nothing but dilution. On adding water, there is no change in pH value. If you add water to the buffer solution, there is no change in pH value of buffer solution. And its pH is slightly changed. The pH of buffer solution is slightly changed by the addition of what? Small quantity of an acid or a base. Its pH value is slightly, very slightly changed by the addition of a small quantity of an acid or base. But the change in pH value is negligible. The change in pH value is negligible. Very small change will occur by adding what? Small quantity of acid or base. But if you add large quantity of acid or base, if you add sometimes large quantity of acid or base, the buffer solution cannot have reserve acidity and reserve alkalinity. The pH will suddenly change if you add large quantities. But if you add small quantities of acid or base, there is no change. That is negligible change, very slight change in the pH value. Okay, and the buffer solutions can be obtained in different methods. By different ways, by different methods, in different ways, we can get what? Buffer solutions. So the buffer solutions can be obtained in different ways. So first one is what now? By mixing a weak acid with its salt with a strong base. So here, now first one, by mixing what now? A weak acid. A weak acid, imagine CH3, COOH. Okay. Now CH3COOH is what? Weak acid, acetic acid. What is the name of this? Acetic acid. So this acetic acid with its salt with strong base. A strong base means what now? NaOH now. Now take here this acetic acid CH3COOH when combines with the strong base. Strong base means what now? NaOH. Strong base indicates what here? NaOH. So the strong base is NaOH here. When this acetic acid, weak acid, reacts with the strong base, what will be the salt form? Tell me, formula of salt. Here Na plus is cation. Here CH3COO minus is anion. Right now. So anion and cation combine with each other. Then what will be salt form here? CH3COONA. CH3COONA will be forming. So it is called sodium acetate salt. Salt called sodium acetate. This ion is what? Acetate ion, CH3COO minus. So sodium acetate ion is formed, salt is formed here. The sodium acetate salt plus this acid. So by mixing a weak acid with its salt means salt of weak acid. Its salt meaning what? Salt of weak acid with a strong base is what now here? CH3COONA. So CH3COONA. So the mixture of this weak acid and its salt. The mixture of what and what here? Weak acid. The mixture of weak acid plus its salt. The salt of weak acid. The salt of weak acid with what? It's a salt with what? Strong base. The salt of weak acid with what? Strong base. So this mixture is called what now? Buffer solution. This mixture is called what? Buffer solution. In this, what is there? Weak acid is there, weak base is there. Along with salt, weak acid is there. So this is an example of what now? Acidic buffer. Which type of buffer it is? Acidic buffer. Why it is called acidic buffer? Because it is having weak acid and its salt. As weak acid is present here, it is called what now? Acidic buffer. As weak acid is there, it is called what? Acidic buffer. Is the concept clear? So the combination of weak acid and its salt with strong base is called what? Acidic buffer. It's called acidic buffer. Is the concept clear? And this weak acid will be having what? This weak acid has a Ka. Ka means what? Dissociation constant of weak acid. Ka indicates what? Dissociation constant of weak acid. There will be Ka value for this. From Ka we can get pKa. Na? From Ka what we can get? pKa. pKa means what? Minus log of Ka value. P power Ka is nothing but negative logarithm of Ka. So for weak acid, immediately we have to recall the value of Ka. There will be Ka for this here. And there will be some concentration of this weak acid, and also there will be concentration of salt. There will be concentration of weak acid and concentration of salt. Both will be there. Okay, ma? So here there will be concentration of salt and concentration of acid. And also there will be Ka value for the weak acid. Okay. So now here for this weak acid, means acidic buffer. Now what is acidic buffer? Example, tell me. For this acidic buffer, pH value can be calculated by formula P power Ka plus log salt concentration by acid concentration. P power Ka plus log salt concentration of salt divided by concentration of acid. Here acid is what? Weak acid. Acid is what? Weak acid. Concentration of this weak acid. And what is salt here? The salt of weak acid and strong base. The salt of weak acid and strong base. It is the concentration of this salt. And the concentration of acid is concentration of weak acid. And this weak acid has the value called Ka. From Ka, how to get pKa? Minus log of Ka. So pKa is equal to what now? P power Ka is equal to negative logarithm of Ka. Okay, the minus log of Ka value is nothing but P power Ka. Okay, if Ka value is greater, pKa will be lesser. If Ka value is lesser, pKa value will be greater. So both pKa and Ka, how they are related? Inversely related, inversely proportional. If Ka value is less, pKa value will be more. Okay, so here pH of this acidic buffer, can be calculated by the formula pKa plus log of salt concentration by acid concentration. Log of concentration of salt to means log of concentration of salt by concentration of acid. So this is the formula for what here? Acidic buffer. This equation is called Henderson equation. Henderson equation. So Henderson's equation is for acidic buffer. For acidic buffer, the Henderson's equation is given by what? pH equals to pKa plus log of salt concentration by acid concentration. Did you all understand the concept now? So it's about what now here? The concept of pH of acidic buffer. Tell me first of all, what is acidic buffer? The buffer of weak acid and its salt with the strong base. Okay, by mixing a weak acid with its salt with a strong base, we get what? Acidic buffer. First step. And second thing you take here. Buffer solutions can be obtained. By first one, what now we discussed here. Weak acid and its salt. Example, what we have taken here, examples important here. First one, what we have already discussed, weak acid and its salt with strong base. It is weak acid and it's the salt with what? Weak acid, and it's the salt with strong base. We have taken first example. Next, boric acid and borax. Boric acid and borax. Remember the names first here. Okay, boric acid and borax, phthalic acid and potassium acid phthalate. Phthalic, here P silent, remember. P silent here. So phthalic we read here. PH silent here. So phthalic acid and potassium acid phthalate. Potassium acid phthalate. The names remember here. So phthalic acid is weak acid and it's a salt with potassium hydroxide. Phthalic acid is weak acid and it's a salt with KOH is taken here. And here boric acid is weak acid and it's a salt with NaOH taken here. Borax is what? Sodium salt of boric acid. So borax is what here? Sodium salt of what here? This one. So here H3BO3 is the formula. This formula you remember. Phthalic acid and all we'll discuss in organic chemistry. But now here remember boric acid formula H3BO3. Okay, the same thing we can also write BOH taken thrice. BOH taken thrice or H3BO3 boric acid. Okay, so and Na2B4O7. Na2B4O7 is borax. Na2B4O7 is borax. And boric acid what? H3BO3. So the mixture of boric acid and borax is also what? Acidic buffer. Why it is acidic buffer? Here we are mixing weak acid, boric acid plus the salt of boric acid with NaOH, strong base. That's why it is what now here? Weak acid and it's salt with strong base. And phthalic acid is weak acid and it's salt with KOH, strong base we have taken. Potassium phthalate and phthalic acid. Is that clear, ma'am? So now here. Now next one, second type of what here? Buffer solution. First type of buffer solution, how to get? Buffer solutions can be obtained by mixing a weak acid with its salt with strong base we have studied. Second type is here. By mixing, buffer solutions can be obtained by mixing a weak base now. A weak base with its salt with strong acid. By mixing a weak base with what? It's the salt with a strong acid. Example you take here. In this case, NH4OH is what? Weak base. Isn't it? NH4OH is what? Weak base. And NH4Cl, how it is formed? How NH4Cl is formed? By reaction of NH4OH weak base, NH4OH weak base with what? HCl strong acid. HCl strong acid. What we got now here? NH4 plus and Cl minus. NH4 plus and Cl minus. Then we got what now here? NH4Cl. So NH4Cl is the salt of weak base and means salt of weak base with strong acid. NH4Cl is the salt of weak base with what? Strong acid. Like that, NH4OH weak base plus its salt with strong acid. It is an example of what? Basic buffer now. Here in this one, salt is there and weak base is there. As weak base is there, it is called what? Basic buffer. So this is an example of what now here? Basic buffer. Basic buffer. Basic buffer contains what? Weak base and its salt with strong acid. Weak base plus its salt with strong acid should be there. This concept should be understood here. And glycine, another example is what? Glycine plus glycine hydrochloride. The glycine molecule. Glycine is one example of what now? Amino acid. This amino acid glycine, weak acid, combines with hydrochloric acid, strong acid to form glycine hydrochloride. So glycine hydrochloride is what? One salt of glycine. Salt of glycine and glycine. So only glycine is what? Weak acid. So weak base, sorry, weak base. And this weak base is mixing with what? Strong acid here. The glycine weak base is mixing with, glycine is weak base. Okay, it is mixing with what? Glycine hydrochloride. Glycine hydrochloride. So glycine. Already we studied once. I have explained this glycine molecule. Glycine formula, how to take now here? It has NH2 amine group, NH2 group, CH2 and COOH. Here nitrogen has what? One lone pair. This lone pair of nitrogen can be donated now. It can be donated. So electron pair donor is called what? Lewis base. Electron pair donor is called Lewis base. And also it can accept one H plus. Proton it can accept. So proton acceptor is also called base, Bronsted base. So it can act as what? This group NH2 group can act as what? Because of NH2 group, this glycine molecule can act as what? Base. Because it can donate electron pair and acts as Lewis base. And also can accept H plus proton and acts as Bronsted base. So both it is base here in both cases. That's why here glycine will be taken as what? Weak base. This weak base combines with what? Hydrochloric acid, strong acid, to form glycine hydrochloride, which is a salt, and it's weak base. So weak base and its salt is an example of basic buffer. For basic buffer, first we have to calculate what? POH. So Henderson equation. Henderson's equation, what now for this? POH or pH, what we take now here? POH we calculate. POH is equal to pKa or pKb. What should be taken here? P power Kb. pKb plus log salt by acid or salt by base. Here what are there? Two components of the basic buffer. One weak base is there and its salt there. So we have to take log of salt concentration. Concentration of salt divided by concentration of base or acid here. Base. Because it is basic buffer. It is basic buffer. So we have to take what now here? Yeah. So we have to take what now here? Basic buffer. So for basic buffers, what we have to take now? We have to take POH. POH is equal to pKb plus log of salt by base concentration. Okay. Is everyone following? Once raise your hands. Yeah. Now is it now what we are discussing is acidic buffer or basic buffer? It is basic buffer. The basic buffer contains what? Weak base along with its salt with strong acid. So in this weak base is there now. That's why we take Kb. Okay. For weak base, what will be there? Kb will be there for weak base. From Kb, what we can calculate? pKb. So pKb formula what? P power Kb. Formula what? Minus log of Kb. Minus log of Kb is called pKb. So if Kb value is greater, pKb value will be lesser. If Kb value is lesser, pKb value will be greater. Okay, so like this here, pKb is equal to negative logarithm of Kb value. So for the weak base, what is there? Kb is there and pKb we have calculated. So POH of basic buffer, POH of basic buffer is equal to pKb value plus log of salt concentration by acid base concentration we have taken. And this equation is called Henderson's equation. And previously what we have taken here, another equation, Henderson equation, what in this case? Henderson equation, pH of acidic buffer. pH of acidic buffer is equal to pKa plus log of salt concentration by acid concentration. So these two formulas are very important. pH of acidic buffer and POH of basic buffer. These two concepts are very important. Okay. Now, so here, suppose imagine here Kb value 10 power minus 5. Suppose Kb value 10 power minus 5. Then what is pKb? pKb is equal to minus log of 10 power minus 5. That is 5. So pKb value will be 5. Place. So suppose salt concentration is 0.10 power minus 1 it takes. Suppose 10 power minus 1. And base concentration 10 power minus 2. Salt concentration, suppose example I'm taking 10 power minus 1 and base concentration suppose 10 power minus 3. Suppose, imagine. Now if you take this one, now salt by base ratio what? Concentration of salt to base ratio what? 10 power minus 1 into 10 power 3. This 10 power minus 3, take it up, 10 power 3. 10 power 3 into 10 power minus 1, 100. Log 100 how much? 2. Log 100 how much? 2. So log 100 will be 2. 2 plus 5 here, 7. POH will be 7. So like that here, values will be given. From given values, we have to get what now here? We have to get this pKb, pH values and POH values. Okay. So here base salt concentration by base concentration we have to take in case of POH. Is the concept clear? Yeah. And now another case now here. Now we can also obtain what? The buffer solutions. The previous case take. Already second exam we have discussed. Now third one. By means what? Buffer solutions can also be obtained by a solution of ampholyte. A solution of ampholyte. So the ampholytes are amphoteric electrolytes. Ampholytes are also called amphoteric electrolytes. Amphoteric electrolytes are the substances which show properties of both an acid and a base. So amphoteric substances meaning what? Both acidic in nature and basic in nature. They have both acidic character and basic character. They are amphoteric substances. And electrolytes means they will dissociate in the solution. In solution, they will dissociate into ions. So they are called electrolytes. So this amphoteric electrolytes, short form what? Ampholytes. Ampholytes. Okay. So the ampholytes are the substances which show properties of both an acid and a base. Example what? Proteins and amino acids. Proteins and amino acids are the examples of such electrolytes. So what are ampholytes examples? Proteins and amino acids. These two are examples of what? Ampholytes. Okay, so the solution of ampholyte, the solution of protein or solution of amino acid will also act as what? Buffer solution. The solution of ampholytes will also act as what? Buffer solutions. Is the concept clear? Examples of ampholytes what? Proteins and amino acids. Next, the buffer solutions can also be obtained by a mixture of an acid salt and a normal salt. Okay, a mixture of what and what? An acid salt and a normal salt of a polybasic acid. Polybasic acid. So suppose I'm taking polybasic acid example H3PO4. I'm taking here H3. H3PO4 is what? Phosphoric acid, right? H3PO4 is phosphoric acid. So this phosphoric acid is polybasic acid. Why? It can produce how many H plus ions? I told you 3 H plus ions. So it tribasic acid. Tribasic acid. It can produce 3 H plus ions. So this is polybasic acid now. So for this polybasic acid, if all the 3 hydrogens are replaced by 3 sodium ions, if all 3 hydrogens are replaced by 3 sodium, we get Na3PO4. H3 becomes what? Na3PO4. So Na3PO4 is what? Normal salt. Normal salt of what? H3PO4. Na3PO4 is the normal salt of H3PO4. And now see here. Now from this H3PO4, imagine only one hydrogen is replaced by sodium. Out of 3 hydrogens replaceable, only one hydrogen replaced by or 2 hydrogens replaced by sodium. Suppose 2 hydrogens replaced. Then how many hydrogens left over? Suppose 1. So HPO4 left over. In place of 2 hydrogens, what will be there? Na2. So Na2HPO4. Na2HPO4. This Na2HPO4 is an example of what? Acidic salt. Why it is acidic salt? Why this compound is acidic salt? Because still this Na2HPO4 can produce H plus. It can still produce what? 1 H plus. So it can still produce what? 1 H plus ion. As this salt can produce still 1 more H plus ion, it will be called acidic salt. This Na2HPO4 still can produce 1 H plus, na? Therefore it is what? Acidic salt. So acidic salt or acid salt and normal salt of the same acid. Now Na2HPO4 is acidic salt of H3PO4 polybasic acid, and also Na3PO4 is normal salt of same H3PO4. Is the concept clear? So from same acid, polybasic acid, we got acidic salt and normal salt. So this combination is also what now? Buffer solution. A mixture of an acid salt and a normal salt of a polybasic acid. Example, Na2HPO4 plus Na3PO4. Or otherwise, a salt of weak acid and a weak base. Now see this one. This is the salt of which two substances? It is formed from CH3COOH weak acid plus NH4OH weak base, right? So the salt is produced from what? Weak acid and weak base. It is weak acid and this one is weak base. Therefore, here from this cation, from this anion, we got what now? CH3COO minus NH4 plus. This is ammonium acetate. Ammonium acetate is the salt of weak acid and weak base. So a salt of weak acid and weak base will also act as what? Buffer. Okay, this type of buffer is called simple buffer. What is called? Simple buffer. Simple buffer means what, ma'am? The salt of weak acid and weak base. If you dissolve this salt of weak acid and weak base in water, the solution obtained is what now? Simple buffer. Okay, see here, the first and second type are also called acidic and basic buffers. The first one is what here? The first one is what? This one. It is acidic buffer, weak acid and its salt. And second one is what? Weak base and its salt. This is what now? Basic buffer. Okay, ma'am. So that's what they are saying here. The first type and second type are called acidic and basic buffers respectively. And this buffer is what now? Salt of weak acid and weak base is called simple buffer. So we can say simple buffers, acidic buffers, basic buffers. Like this mainly we classify. Is the concept clear to